let's start off. Hope everyone tried the homework problems. Everyone got the answers for the 38 one? Anyone got? Other scams on? Are these people, why they are so late? Sure, let's see. Step one. Other scams on. Rehan, Swastika, Yasha, cams on. Step one, FBD. So let's draw the rod guy FBD. Since there are two different strings, tensions also will be different. So T2. T1. This is the top view. And this is connected to this block here. So it will have the same tension T2. Weight is 2 mg. This guy is connected to this block here. Tension T and the weight is mg. Next thing, acceleration profile. So let this rod go with A and rotate with alpha. That means this topmost point is going with A plus L by 2 alpha. This bottommost point is going with A minus L by 2 alpha. And since this is connected to the string, this should have an acceleration A plus L by 2 alpha, and this should have an acceleration A minus L by 2 alpha. If you got till here, you did almost 60% of the question is done. 60% yes, 80% of the question is done. Only solving and equations are left. Please check out this thing. Did you get the FBD and the string constraints right? Maximum, right? Always try to avoid as many variables as possible. If you can represent the block accelerations in A and alpha, don't bring A1 and A2. Meaning nothing wrong, but when you simplify anyway, it goes off. Now for the rod, the force equations. This is A and this is alpha. I hope you guys are observing, how detailed we write each FBD constraint equation. Now, when you do like this, the chapter won't find difficult. The reason, most people find rotation tough is because they don't do it in a systematic way. And top of it, there are too many things coming up. The questions are tough. And on top of it, if you don't do in a proper order, it'll go for a toss. Meaning, even when you do a mistake, right, you won't realize where it went wrong. Right. So there's nothing there on the previous page, Adirath. Just homework questions. Didn't do homework questions. Tried. That's why I sent 1 hour before also reminder. I know some of you must have forgotten. Hope you must have spent some time on these things. Then Ali, cam on. Force equations. T1 plus T2 is equal to MA. This is your equation 1. Talk about the center of mass of the rod. T2R minus T1R is equal to I center of mass alpha. Be careful with the signs. T2 is in the direction of alpha. T1 is opposite to alpha. That's why I took a minus sign. So don't randomly. I'm not taking torque directions randomly. Should be clear which sign you're taking. And this guy would be T2 minus T1. Let's not write it as R. T2 L by 2 minus T1 L by 2 is I center of mass alpha. This guy would be ml square by 12 alpha. Then this would be T2 minus T1 is equal to ml alpha by 6. This is your equation 2. Perfect. And for the blocks, 2mg minus T2 is equal to 2m a plus L alpha by 2. That's your equation 3. So the other block mg minus T1 is m into a plus m a minus l alpha by 2. That's your equation 4. There. 4 equations, 4 variables, t1, t2, a and alpha. Now solving, physics got over here. Now you need to understand how to solve. Meaning, now see, sir, so many equations, how to solve. Now this, you will get a hang of how to solve when you do practice. So when you're practicing at home, right, make sure you solve till you get the answer. You know what some of you do? Some of you do like, sir, equations आ गया ना, इसके बाद solving है, मैं exam में कर लेता हूँ. Exam में नहीं होगा, boss. Because you're not used to solving. Exam में you get frustrated when you see this many equations instead of solving. And advanced में questions are lengthy. कहेंगे advanced में questions are lengthy. Tough का बात अलग है, and questions are lengthy also. So now only when you do that practice of solving, you'll understand, अरे ऐसा equation है तो मुझे ऐसा करना चाहिए. Now, when I clearly see here, I'm getting a feeling here. There's a T1, T2 here. There's a T1 plus T2 here and T2 minus T1 here. So from here, I can do 3 plus 4 equation. If I do, that will become 3 mg minus T1 plus T2, that is ma. Now you need to skip steps. And this guy would be 2 ma. This will be 3 ma plus ml alpha by 2. I wrote T1 plus T2 is ma directly. Next thing, if I do equation 4 minus equation 3, that would be mg minus 2 mg. That would be minus mg. That will be T2 minus T1. So that will be ml alpha by 6. And this guy would be ma minus ma. So minus ma minus ml alpha minus 3 ml alpha by 2. There, I eliminated T1, T2. I have two equations in terms of a and alpha now. I think this much so you can do now. I will leave it to you. Find a from here and alpha from here and you're done. Please check the equations. If you got the equations right, you're done. Solving part is a different story. Can someone solve and tell me what is the answer for this? Any steps? Anyone not convinced with the FBD? Any equation here? Please ask. Wow, these people who are missing. Arjun, you're there. Aryan, you're there. Rehan, Balakshmi. Hmm. Clear with this? Any doubts on this? Anyone got an answer? Solve it. You will get it. I will leave it to you this thing. What about this guy? Alpha is 6G by 5L. I don't know the answer, so I have to trick it. Anyone else got it, so fine. And don't write A is equal to R alpha. That doesn't work. A and alpha directly have no relation as such. Diamonds are not matching, Aryan. Okay, that is fine. What about this guy? Anyone got an answer for this? What is the acceleration of the cylinder? Tell me that. If you got that, I'm sure you got the answer. What is the acceleration of the cylinder? Did everyone try? How many of you tried? Raise your hands. Most of you forgot. Try. I'll give another 2-3 minutes. Abhi try kar. I told you only last class. Try karke aao because these questions are long. You will need 7-8 minutes to try each one. Try. Each one is a proper advanced paragraph. You know, this will be a proper advanced paragraph question. I'll ask you acceleration of the cylinder and I'll ask you kinetic energy of the system. And remember, no matter what problem I gave, the process is the same. FBD, assign accelerations and alpha, relation between them, force equation, torque equation. So this is the same story I'm repeating from last class. Let's get this. Acceleration of the cylinder is interesting. That is right, Adrit. Shall we get the remaining now? Let's see the FBD. How many of you got that right? Tension, friction, capital F, friction, tension. I'm not writing the vertical forces. Okay, N and mg I'm not writing. That's it. Any other forces? There are no other forces. Next thing, define your accelerations. Let this go with A. Let this go with alpha, and let this go with A Planck. At this point of contact, this acceleration will be A minus R alpha. At this point of contact, the acceleration is A plus R alpha. And at this point, the acceleration is AP. And this point is connected by a string to the Planck, and this point is also AP. There are two constraints here. The first one, A minus R alpha is equal to AP. This is the no slipping condition because they're touching each other without slipping. That should have nothing. Second thing, acceleration along the string should be same. A plus R alpha. Now be careful here. I took both this way and this way, but in this direction they should be same, right? You're getting how it is? Acceleration along the string should be same. So A plus R alpha is minus AP. I hope you're getting why I'm taking the minus sign. This point acceleration in this direction should be equal to this direction. But for whatever convention I have assumed, I took AP to the right side. So you take care of the sign. So you have to be careful there. You can assume whatever directions you want, but the signs you have to be careful. So this guy would be minus AP. This is the string constraint. Acceleration along the string is same. So there are two constraints here. If I ask you this question now, this will be a proper mains level question. Find acceleration of cylinder. Now, if I add these two equations, you end up with 2A is equal to 0. Let's call this equation 1. Add the above equations. If you add the equations, you will get A is equal to 0. Cylinder is not moving only. A plus R alpha, A minus R alpha, the R alphas will cancel, APs will cancel, A is equal to 0. And that means AP is equal to minus R alpha. There, that's your no constant equation. Now try. Now apply the force equations, torque equations, and solve. That means this cylinder is not moving. I assumed alpha this way and I assumed AP this way. Now it is just a matter of writing equations and solving. Please check the string constraint on that no slipping condition. Palak, clear with that? Got this thing now? Aryan, clear with the constraint? Rehan, Lakshika, got this? Solve. Get me acceleration of the Planck and alpha. That's what I asked. And the kinetic energy after time. So if I write the equations here, I get T minus F is equal to 0. So T is equal to F. So if I write torque about center of mass, it would be, now you have to be careful here. See, something happened wrong here. TFR, wrong nahi hai. TR is equal to I into minus alpha. You have to be careful. Don't directly take alpha, because if you see F ka torque is this way, T ka torque is this way, but alpha you took this way. Got it? So torque and alpha. So that is the reason actually, you got a minus sign here. AP is equal to minus alpha. That's why we got this. Meaning the direction I have taken is wrong. So the max is trying to adjust it now. So, and F is equal to T. So this guy would be 2TR, and it's a solid cylinder. So minus mr square by 2 alpha. So T should be minus ma Planck by 4. And then for the Planck equation, F minus T minus friction is equal to MAP. That is F minus 2T. So that will be, and 2T would be, T substitute here. So MAP plus 2T will be minus MAP by 2. Sorry, this is plus actually, because R alpha is minus AP. So this is MAP here, 3 MAP by 2. So acceleration of the Planck is 2F by 3M. Check. Once you got AP, you'll get R alpha, everything you'll get. Just a matter of equations. What is the second part of the question? Find the kinetic energy of the system after time t. How do you do that? That's a pretty good one, actually. I know I didn't teach you still energy, but there is a pretty fast way to get the answer. Normally, people just find the kinetic energy of the Planck, cylinder, everything, and add it up. But remember work energy theorem? What is work done by all forces? Change in kinetic energy. Now, that kinetic energy, I don't care whatever it is. Planck, cylinder, everything included, because friction is anyway internal. Now, what is work done by a force? Anyone can tell me the definition? What is work done by a force? A proper full definition. You can unmute and just tell me, anyone. Ali, work done ka definition. Please give us the definition for work done. Whatever you remember, Ali, you can just tell me the definition. You can hear me, right? You can't hear it. That means you're not there in the class. I should kick you out. No? Okay, you can hear me. Ali, definition for work done, please. If you don't know, you can just unmute and say, I don't know. That's also fine. You have a robotic voice. Ali, you know, you don't know. Okay, your mic is gone. Or it might be a new setting where you need not answer. Not bad. Let's see. Vartika, definition for work done.
I'm not sure. Sorry.
You're not sure about this? Like, chapter got over 2-3 weeks back. वर्क डन का डेफिनेशन रहे, और कुछ नहीं पूछ रहा हूँ.
I don't know my definition.
Come again.
I don't remember that definition.
Swastika, work done का definition. Now I can see how much you guys are putting effort. बहुत दिख रहे हैं. हाँ, Swastika, definition of work done. नहीं, that is not the full definition. That's not the definition only. Work done का वो नहीं था statement. आदित्य, work done का definition.
Force into displacement in direction of force.
No, that is bullshit. That is not what I said. You got it. Abhinav, work done का definition.
The integral of fs cos theta.
Okay. Can you elaborate a little more? What else? There is something more important than that. You could have said integral f bar dot ds, where ds is the displacement of point of application of force. Or, chalo, force into displacement of point of application of force. If f is constant, you can remove the integral. Force into perpendicular distance nahi hai. So be careful. Read your definitions. If you guys are struggling with such a small thing, I don't know what you guys are doing exactly after this much. Work done by all forces is what? Force into displacement. Which displacement you should take? Force into displacement of the point here, f is constant. Displacement of the point where you're applying the force. That is this point here. That is equal to change in kinetic energy. What is the displacement of that point? Force into half acceleration of the plank into t square, isn't it? Constant acceleration. You're done. That's your answer. The total kinetic energy of the system is work done by the force. And the force is, work done is force into displacement of the point where you applied the force. And the point is having an acceleration AP. So displacement is half AP t square. Clear with this? That's what makes the second question so nice. It is not tough to solve, but most people read it doesn't click. So what they do, they find the kinetic energy of the plank separately, they find the kinetic energy of this cylinder separately and add it up. You get the same answer, but that would eat away at least 2 minutes. Clear with this? Any doubts on this page? Next one. This is another pretty good one. I told you to try these things. Some of you didn't even bother after telling so much. Try this thing. Get the first one. I'll give you a minute for the first one. 2 minutes for each. There is a hinge, there is a string, and there is a spring. How, in each case, how does each thing behave? First one. First one is the easiest one actually. This is the hinge here. Write the forces. Ny, Nx, Mg. You're just asking for alpha, so I'll not write anything else. So done. The alpha there. Extend the vector. Drop the perpendicular. So this guy would be L by 2. So torque about the hinge will be mg L by 2 and I about the hinge into alpha. So mg L by 2 is equal to, that would be how much? 2 by 3 ml square. Parallax's theorem, if you remember. I about hinge will be I center of mass plus ml by root 2 whole square. And I center of mass is ml square by 6. Alpha will be 3g by 4l. A better question would have been find the hinge reaction. That would have been fun. So if you want to do that, this is the hinge. This is alpha. This is center of mass, and this is going in a circle. So this would be the acceleration of center of mass, which is L by root 2 alpha. And you can resolve this into components ax and ay, where this angle is 45. And then from there you do n by nx ka horizontal forces. If you write, you will get the hinge reaction if you want. I didn't ask you that, but you could have done that. If they ask you hinge reaction, you don't have an option. You have to find acceleration of center of mass ka horizontal and vertical components and then write the equations. Clear? What about the second case? If you have both the strings and you're cutting one, please have a look at this page. Any doubts on this? Arjun, clear now?
Yes, sir.
Utsa, got this? Maulika, Vartika, clear? Get the second one. So how is this different from a hinge? B is a, out of three, the B is the deadly one. Try, I'll give 2 minutes for that. See the second one. The problem with the second one is, There's a force T here, there's mg. That's there are only two forces. Nah, it is not the same. There are only two forces. There are no horizontal forces here. And second thing, do you think this is at rest? If you leave this here, after some time, this is what you'll observe. This point A here can actually oscillate, isn't it? It is a non-inertial frame. You can't take torque about that point. If you can't take torque about that point, then you have to take torque about center of mass. And if you take torque about center of mass, I don't know the value of tension now. Isn't it? The previous case, you took torque about the hinge and NX and NY both got eliminated. Here, you don't have that luxury here. Previous one, we could have taken torque about center of mass and we could have got NX and by you'll still get stuck na in the previous question. Then NX and NY both torques will come, right? You're still stuck with an equation with two variables. You need a second equation.
NY mg नहीं हो जाएगा क्या?
Q, matlab you're assuming the center mass is at rest. Or are you assuming AY is 0?
Oh, okay.
Be very careful. When you say it is at rest, that's a big trap. So you're getting the problem here. The problem is this point is moving, but there is something here. This problem has, a lot of similarities with this guy. Can you observe here also the forces are only vertical? So when the forces are only vertical, what happens to center of mass? It just has to go down. It can't go left and right. Make sense? So at least that much, since there are no horizontal forces, a center of mass moves downward. So if you write the acceleration profile, so the center of mass is going down and this is also rotating alpha. Now the interesting point is this guy here. If you look at point A here, this is going down because of A and it is also going in a circle like this, L by root 2 alpha. This angle is 45 degrees. So acceleration of point A along the string should be 0 because string cannot stretch. That means A minus L alpha by root 2 cos 45, the vertical component should be 0. A is equal to L alpha by 2. Does that make sense? If you see that previous problem we did, the rod thing, isn't it the same story we did? At this point A here, the vertical is 0 because there's a floor, rigid body constraint. The same logic here, because the string cannot stretch up and down, right? At this instant, the vertical acceleration is 0. This is your constraint equation. Since string cannot stretch. And then you're done. So this guy would be A and this guy would be alpha. Vertical is mg minus T is ma. Torque about center of mass. So here A is non-inertial frame. So I can't use it. That is a problem here. If by chance you take about A and do this, you will be gone. So if you take torque about center of mass, this is the perpendicular distance. So T into L by 2 is equal to ml square by 6 alpha. T would be ml by 3 alpha. And this guy would be 2ma by 3. Let's take this and substitute here. So A would be 3g by 5. Check. And take goof up. 3
No.
2ma by कुछ तो messed up है ना? We did a mess up. T is ma by, yeah, looks right na? L alpha is 2a, so 2ma by 3. I took it and kept it there. So it will be 2 by 3 plus 1 is 5 by 3. So looks right. Check. I hope I didn't do any calculation mistakes. Or did I? So once you got A, you're done, right? A आ गया तो alpha भी आ जाएगा. Please check the steps. So in this question, for a string, you need to realize that the point A can move and tension can change suddenly, so it doesn't work. That's the difference between a hinge and a string. What about a spring now? That is even fun. So what if you have two springs and you cut one of the spring? Any doubts on this page?
So
Anusha, clear, na? Arjun.
if we talk about A, the pseudo force would only affect the linear dynamics equation, right?
है सेंटर में टॉर्क भी आएगा ना गॉड. अभी ये पॉइंट का एक्सेशन कितना देन इट विल बी दिस वे ना एल अल्फा बाय 2.
हाँ, all right.
हॉरिजॉन्टल है ना, वर्टिकल नहीं है, हॉरिजॉन्टल है ना. तो इफ यू स्टैंड ऑन ए तो एक सूडो फोर्स आएगा इस तरफ एम एल अल्फा बाय 2 भी आएगा.
Okay, got it.
So when you take torque about this, abhi you have to take torque about this guy also.
Right.
You'll get the answer, but if you have done this, why you want to unnecessarily bring pseudo force again?
No, just I wanted to understand what.
That would be a mess. No, it's a good thing. You should know, like, if you have taken what kind of mess it would be. That is important. See, it is not always about getting the right answer. You should always know, like, if I have done this, I might have got the answer, but it would be messed up. There will be too much solving. If you don't realize that in the exam, when you see a question, you won't get a judgment how long will it take to solve the question. And if you don't get a judgment how long it will take to solve a question, you won't understand whether to leave the question or go ahead. It's very important in the exam when you see a question, you should have an estimate. This question I can do in a minute. This question will take 3 minutes. Roughly. If you can get that judgment, it helps a lot. So if I know there is a question which I know how to solve, but if I'm sure it is going to take 3 to 4 minutes, why the hell will I do it in the beginning? I will just put his mark for review. I will go ahead. Maybe there are some easy questions in chemistry which I can do in 1 minute. Why should I do this one question in physics for 4 minutes? End of the day, no one is going to give you a prize for getting good marks in physics or maths or chemistry. What matters is your overall. What about the springs? You got a minute? Springs are interesting. Let's see what will you do. Okay, you need to define what is non-inertial trim, Ali, then. What is non-inertial trim definition? See, when you ask me something, that means you know, right? You're asking how is a non-inertial trim. So I'm asking you what is non-inertial trim. If you can define me that, it'll be more easy for me to explain. Can you just tell me what is non-inertial trim? See, giving you answer is not difficult. I'll just tell you in 5 seconds. But you will never learn. Can you try at least what is non-inertial trim? Others, you can complete solving the problem first. Just type the message, like whatever you think is non-inertial trim. A non-inertial trim is anything that accelerates. Fair enough? So that means if this point A is moving, it is accelerating, isn't it? Simple. That's it. That is a non-inertial trim. Anything that accelerates is a non-inertial trim. Fair enough? Springs, anyone? What is the specialty of the springs?
Can elongate it.
ठीक है. Can you tell me something in terms of tension? What is the difference between a string and a spring regarding tension?
So the tension in the string won't change immediately, like just after cutting.
Come again?
the tension in the other spring, which is not cut, it won't change immediately, just like after that.
Spring's cut tension does not change suddenly. If you cut one spring, the other spring doesn't care. Because if you think about the springs, the spring force is what? F is equal to kx. As long as the x is same, the spring doesn't care what you're applying. For example, let's say in a string, if you apply 100 Newton, tension is 100 Newton. If you suddenly make this 200 Newton, tension also becomes 200 Newton. The tension in a string can change suddenly. But if this had been a spring, and if you apply 100 and spring is in equilibrium, spring force will say, okay, we are in equilibrium, so kx is 100. And if you suddenly make this 200, spring will say, I'm going to apply kx, which is still 100. I don't care. But because the forces are not balanced, the spring will start stretching and then the force will increase. So you have to give some time. Do you remember we have done NLMA, these kind of problems, cutting of springs? That's where we have seen these cases. So the springs cut tension won't change just after cutting. It takes time. So question is anyway just after cutting. So draw an FBD. So the springs, right, they look deadly, but actually these are also easy. Spring forces Kx, mg, equilibrium. So 2kx is equal to mg. So just after cutting, the spring force will be still kx, which is mg by 2. Your weight is mg. Now I don't know how this is going actually. I can take ax. I can take actually there's no vertical force here. So perfect. This is a, this is alpha. We'll take torque about center of mass. That would be kx into L by 2 is equal to I about center of mass is ml square by 6 alpha. And kx is mg by 2, so mg L by 4 ml square by 6 alpha. So alpha would be 3g by 12. What about acceleration? There is no horizontal force, God. A will be g by 2. There is no horizontal force. So at this instant, the square plate is coming down and rotating. Next moment, it can get messed up. That's a different story. At this instant, this is the story. Next instant, I don't know what to do. So A and C are the good ones, easy ones. But they're proper mains level questions, A and C. B is a advanced one. That would be the difference between a string, hinge, and a spring. The idea is important. Please have a look at this. You should definitely try this problem on your own. So I can write a statement here. Just after cutting, the spring force does not change. Clear? Next one. There. See, 3 good problems. Took us 45 minutes to solve. And that's why I said try it. Those questions were worthy of time. Next one. Plank here, cylinder here. This is the ground. This is MR, solid cylinder. Assume the plank does not fall down. It is somehow balanced. Or chalega, fine. You can give 2 cylinders, big deal. There, both are solid cylinders, MR. No slipping. Both the solid cylinders MR, plank is also M, and someone is applying force F. Find acceleration of the plank. No slipping at any surface. Get this. Two cylinders, you kept a plank on top of it. There's no slipping at any surface, meaning even the plank and the cylinders are not slipping. Cylinders in the ground is not slipping. Process is the same. Here I can tell you one thing, see, because both the cylinders are symmetrical, if you can draw one cylinder FBD, that is sufficient. दोनों का draw करने से कुछ फायदा नहीं है. You'll get the same values anyway. You know, how can you make it more deadly? You can have one is a solid cylinder, one is a hollow cylinder. That would be deadly. Then you'll have F1, F2, F3, F4. 4 frictions you'll get. That would be deadly. But okay, let's not make it deadly for now. We'll just keep it. Both are solid cylinders. That would have been fun. Meaning, FBDs and constants is fun, equation solving will be irritating. Let's say both are solid cylinders. Try. Just give it a try. I'll just get some water and come. Eight F by 11 M. Interesting. Anyone else got that thing? You have one answer from Aditya. 2 alpha R. What is alpha? Let's see. First FBDs. Let's see how many of you got the FBD right. F by 2M. Lakshika, that answer looks too innocent. Actually, I'm not sure though. So if I take this guy, see your FBDs, huh? Most people just goof up the FBDs. That's a problem. If you can't draw a proper FBD, you can forget about the question. That is a step one always. There is a friction here. I'll call it F1. There will be 2 frictions. Hope you have drawn 2. Next thing for the cylinder. This would be F1. This would be F2. I'm not writing the vertical forces. F1 and F2. That's why I said you can draw one cylinder. That is fine. Now for the cylinder, I'll take this as A and this is alpha. So at the topmost point, the acceleration will be A plus 2R alpha. Sorry, A plus R alpha. So acceleration of the plank will be A plus R alpha. The bottommost point is A minus R alpha, which should be equal to A ground, which is 0. So A is equal to R alpha. So this guy is actually 2A. There I wrote all the constants on the same FBD. So this is A and this is alpha. Perfect. Now for this guy, F minus 2F1 will be mass into acceleration of the plank, which is 2ma. Now when you see the equation, I clearly know if I know F1, my job is done. And you know the best point to take torque about A, because if I take torque about A, F2 goes off. Torque about A will be F1 into 2r is moment of inertia about A into alpha. So F1 into 2r is a solid cylinder. So parallax's theorem, 3mr square by 2 alpha. We might get a good answer. This F1 will be 3mr alpha by 4, which is 3ma by 4. Because A is equal to R alpha. Take this and dump it here. F minus 3ma by 2 is 2ma. 7ma by 2. Interesting. I didn't expect something like this. Please see, did I goof up anywhere? Check the equations. Equations are, or maybe you guys forgot two frictions. Cylinder का just take torque because I don't want F2 anyway. I just want A, तो हो जाएगा. F1 into 2r IA alpha. Solid cylinder तो parallax theorem mr square by 2 plus mr square. That is also right. Looks right now. Check. Did I go up anywhere? Question was not really that difficult if you see. Just two equations, we got the answer. Main thing is you need to draw a proper FBD. If this had been a hollow cylinder and hollow this thing, then this would have been F3, F4. This would be A1, alpha 1, A2, alpha 2. Nay, but luckily, A1 will be equal to A2 actually. Because this point is not slipping, so this point should have same acceleration. This point should have same acceleration. Accelerations will be same, but the forces will be different. Then bloody you'll get 4 frictions, you will die actually. Okay.
So
Have a
how
look at
would if slipping is taking place?
it is given no slipping.
No, sir. If they say slipping happens,
Then question is happy, right? Done. F maximum, F maximum.
okay.
The problem is you don't know the values, right? If it is slipping, then you're happy. F maximum. And what is F maximum? N1 plus N2 is mg, N is mg by 2. So friction maximum is mu mg by 2. Done. Clear with this? Next one. Turn in the page.
So can you go back for a minute? Yes, sir. Thank you.
Udayan, Anika, when you are late, you need to at least inform. Udayan? Where did you go? Movie? Party? Ice cream? Something? Tell me something interesting. Don't give boring reasons like I slept. Lunch late ho gaya. Those are boring. Say something interesting like Godzilla attacked my house, I was fighting, so took time. That would be nice. Anika, you have something like that? So there is one time in a class student was late. I told him something like that. Only if you can give me an excuse where it looks completely unbelievable, I'll let you in. Then he said, I'm coming in a train, the tire got punctured. So I had to get down and start pushing the train. So I came to the station and it took time. I said, yeah, that's a good one. I said, Ajo andar. So yeah, you guys are going to IIT, re? Itna hona chahiye weirdness. Now let's see. This shape, I don't know what it is, but let the moment of inertia be I. So that could have been solid cylinder, plan, this could be anything. High touch. So the question is, find the acceleration and time taken to reach the ground. The result is a good one for mains level and bits. I could have derived it, but let's get this. This is easy. Step 1, FBD, accelerations and none. See, mg sine theta, mg cos theta, normal reaction, friction. This is the acceleration and this is alpha. This point is the best because it's not accelerating anyway. So if you take torque about A, that would be mg sine theta into r is equal to I about A into alpha. So alpha would be mg sine theta r by I center of mass plus mr square.
The wedge isn't accelerating, teacher.
नहीं वेजेस फिक्स्ड है उसको मुंह मत कर
Okay.
इतना डेडली भी नहीं करते उसको
No, I was busy solving that, so I thought.
नहीं that will be very deadly actually because constant equation also will get messed up a is equal to r alpha नहीं आएगा this would be g sine theta by I by mr square plus 1. There, that's a good result to remember. So a is equal to g sine theta by I by mr square. Did I teach you radius of gyration?
Nice.
No, sir.
I keep forgetting that every time. Let me just teach you what is that. There. So there's a good result. Like I tell the medical students to mug it up. You guys can derive it or remember it anyways. What is the time taken? That is easy. S is equal to ut plus half at square. And S is h by sine theta. Acceleration is half at square. From here, get the time also. Check. Easy. Just let me teach you this thing. So radius of gyration symbol is k. What this thing says is the distance at which the total mass must be located must be placed from axis to get same moment of inertia as the system. This thing, right, is not actually a big concept. This is actually more of a practical thing. Think of like this. Tomorrow, when you go to a lab and you're doing an experiment, right? Who cares like what is the shape and all? Who will remember all these things? So what these people do, right? So on the body, whatever it is, let's say this is M and R. So this theorem, this thing says, if you assume all this mass is at a distance k, so this moment of inertia will be mr square by 2 is equal to mk square. So k will be r by root 2. So this is radius of gyration of the disk. Suppose if I give you a solid sphere. Same idea there. Take all the mass, keep it at a distance k, such that it should give you same moment of inertia. So what they do in the lab, right? Let's say you have a sphere or something. So it will be printed on top of it. Mass is 100 grams. Radius of gyration is 10 centimeter. So you can simply write moment of inertia of any system is mk square. So you can write I is equal to mk square for a system. You need not care what is the shape. Who will remember disk ka formula ye hai, hollow sphere ka formula is that and all. So instead of printing the radius of the body, they will just print, they might print radius also, the extra information, they'll print k ka value also. So if you take any body for rotation, mass is printed, a radius is printed, and k is printed. So radius of gyration is simply mk square. You need not bother about what is the shape. So this is more of a practical, advantage, use in a lab rather than any concept. Clear what is radius of gyration? So just find the total moment of inertia, write that equal to total mass into k square. Aditya, when it lands on the, we are taking the height h is from the base ray. I know what you're saying, but let's not consider that. We'll take the height is from the base only. Clear with the radius of gyration? So we will take this height to be from here. We are ignoring the height of that. Now, this question, right, we can extend it further. So if you release a ring, solid sphere, hollow sphere, and disk, arrange them in the ascending order of time taken to reach the ground, then who will reach first, second, third, and fourth? So you're releasing ring, solid sphere, hollow sphere, disk, and all. Arrange them in the ascending order of time. This is the standard equation. Came multiple times in different exams.
So can you go back for just a minute? Yes, definitely.
Easy there. This formula is there. Dekho na, answer is here only.
Yes, I forgot to note it down.
Whoever has more moment of inertia will have less acceleration.
Yeah,
If
yeah.
you have less acceleration, it will
I
take
got
more
it.
time. So if I is more, A is less. Logically, you can think like this also. See, higher the moment of inertia, it requires more energy to rotate. That means you have less translation energy. That means you have less speed. Therefore, more time and less speed. So if you see in this order, time taken, the one with the more moment of inertia is whom? Ring. The ring will take the maximum time. Then follow sphere, 2 by 3 is 0.6. Then disk. Then solid sphere. So solid sphere will reach first. Similarly, if we talk about velocities, it is reverse. V ring, V hollow sphere, V disk, and V solid sphere. Please check. Clear? Now, this is the standard one. Now we can have variations in this. Suppose the same question. Can I turn the page? No, in this the variations. So the easy way to remember is this, huh? If you don't remember the acceleration formula, also remember like this. If you have more moment of inertia, it takes more energy to rotate. So if rotation has more energy, then translation will have less energy because total is the constant. If you have less translation, meaning you have less translation speed, so it will take more time to reach. So the same thing, what if you have a sphere, mass m1, r1, solid sphere. Let's say we have another bigger sphere. काम करते हैं. Let this be mass m and radius r. This would be 4m and radius 2r. No slipping. Who will reach ground first, the bigger sphere or the smaller sphere?
So the bigger one.
Mm-hmm. Type your answer, no? Type your answer. So we have one small, two big, two small, two big, three big, four big, five big. Okay. 6, 7, 8. Oh, you're only saying big. Chalo dekhte. Why 8 is big? Okay. We have one more small. Small people are minority. ठीक है? All of you are wrong. That's the best part. देख, A is equal to G sine theta by I by mr square. I know I told you I use more, so this is there, but you're forgetting something. What is I का value for solid sphere? G sine theta by 2 by 5 mr square by mr square plus 1. Mr square cancels off. As long as the shape is same, the acceleration is same, it doesn't matter. Isn't it? M and R bhi ho rahe hai na? MR is getting cancelled there. What you're interested is I by MR square. In this question, right, all the shapes had same M and R. So we had to compare only I. But here M and R also changing. So the acceleration, right, is independent of the shape. As long as it's a solid sphere, you take different density, different radius, do any nonsense. Make sure it is uniform though. A is independent of M and R. Depends only on shape. So if you take a small or a big solid sphere, they reach the ground at the same time. Clear? That's a tricky one. What if the same question, now there is a insufficient friction, it slips. So now if I keep solid sphere, hollow sphere, who will reach first? But what is this M then, God? This M is also 4M and 2R, right? Anusha? That I by MR square, this M and R are also the same, 4M and 2R, isn't it? Doesn't matter. Solid sphere, disk and ring. Now who reaches first? Okay. We have one answer. Maulika. Others? Okay, ring reaches first. Adrit, Molika. Okay, we have two answers. Aryan, you are wrong. Ali, you're wrong. Vartika, you're wrong. Answers, everyone. Aditya, Arjun, Rehan, answers. Utsa, answers. No, Swastika, that is wrong. Okay, Abhinav, you are right. These questions, right? C and D are like, they're good ones, right? Proper meaning. These are the kind of questions, right? Either advanced may they can ask in more than one choice, or a mains may single choice questions. See, FBD. Start with an FBD. You'll see clearly see. What are the forces? Mg sine theta. Since it is slipping, friction is max, which is mu mg cos theta. So what is the acceleration? Mg sine theta minus f max is equal to ma. G sine theta minus mu g cos theta. Independent of shape. It doesn't matter what you keep. They behave as good as like a blocks. So when slipping happens, so if there is a slipping, it doesn't matter how much it rolls and let it do any nonsense. If there is slipping, they just behave like blocks. All have same acceleration. They're similar to sliding blocks. Therefore, all have same time. There. So there are some of the variations, which you can create. Have a look at this. Is it possible body slips and rolls at the same time? I think, see, Adrit, don't get confused between pure rolling. Let's try to understand what is the meaning of slipping. At the point of contact, there should be no relative velocity, isn't it? That is the meaning of slipping. Rolling is different. You can roll, but maybe it is not. For example, dekho. Let's say you're going with V this way and you're rotating omega this way. At this point, it is V plus R omega, right? This is slipping, but rolling. You're getting it? So rolling has nothing to do with slipping and no slipping. Got it? When you're going on a cycle and if you suddenly press the brakes, your wheel is rotating, but it is skidding. Or a wheel which gets stuck in a mud, the wheel is rolling, but it is not, it is slipping. Got it? Slipping has nothing to do with rolling. Pure rolling meaning it is not slipping. There's a way of saying it. All clear with this? Easy? Good one? If you see these two questions are a proper trap, you will see this and you'll think like, most people will relate to this. They're nothing related to that actually. It's a good one. Next thing. Rotational kinetic energy. So till now, if you see that all the last problems we did, they are like NLM friction. Now work power energy and circular motion. So rotation is like that, we're getting everything. So problems in this thing will look quite similar to work power energy, state 1, state 2, conserve energy, same stuff. And the only extra thing is rotational kinetic energy. So consider a body is rotating with omega about an axis. So on this, consider a particle Mi going circle here of radius Ri. So this velocity vi will be ri into omega. So kinetic energy of this ith particle will be half mi vi square, which is half mi ri square omega. Therefore, kinetic energy of the system will be sigma kinetic energy of all the particles. This would be half sigma mi ri square into omega. And we know what is sigma mi ri square. Half I omega square. So kinetic energy about an axis is half I about that axis omega square. This is the formula for pure rotation. So the kinetic energy of a system is half I omega square when the body is in pure rotation. So you can't use it for anything. If the center itself is moving, that's a different story. And if you see the resemblance, it kind of looks like half mv square. Example, suppose if you take a disk, and if you say it is rotating about the edge with omega, mass m and length L, the kinetic energy of this plate will be half, and the moment to finish over the edge 2 by 3 ml square omega square. Ml omega square by 3. Check it out.
So that is omega square, right? In first and second step.
You're right. Clear? Take a break. Come back by 7 o'clock. We'll continue from here. So any doubts so far? Anything that we didn't understand, not clear, missed out, please ask. Or let's go take a break and come by 7.
So,
Bino.
but can you show the 41st sum?
41st. कौन सा page है वो? In this one?
But in this one, if one ball is slipping and the other is not, then
How do you know that? They have to mention that.
no, if they mention that one ball is
Then
slipping
whichever is slipping, uska friction maximum लेना.
and the other one we make the
Don't know.
diagram same as this.
FBD will be same. Only
Oh.
three. If you're saying you're slipping, you just take F is maximum. और कुछ नहीं.
Okay.
सर
हाँ अनुषा.
सर मुझे यही डाउट था कि हम लोग इतने बार जो एफ लेके रहे लाइक स्लिपिंग के लिए तो वो मैक्स ले रहे हैं कि नॉर्मल एफ लगा रहा है कि
We don't know, na. We are just taking F. That's a. This friction is always what you call F is less than equal to mu n.
सो सर नो स्लिपिंग के लिए कंडीशन तो है ना कि एफ लगेगा बट वी डोंट नो हाउ मच एफ इज देयर राइट
हाँ. We can calculate it. For example, देखो इसमें किया था हमने equation. देखो इसमें किया था ना F.
यस
So
हाँ
this should be less than equal to mu n. So we are assuming you have given enough sufficient friction so that it will not slip. तो मैं वो भी पूछ सकता हूँ ना. If you remember, there was a question we did. Find a mu minimum so that it doesn't slip. देखो ये question में किया था याद है? So if you just simply tell me it is not slipping, then F is this much only, done. Meaning I require this much friction for not slipping.
And so I had one more doubt.
Mhm.
So today I think the 40th question we did in the B part.
40th का हाँ.
सर उसमें आपने पहले L by root 2 alpha क्यों ले लेकिन पहले कंपोनेंट लिया फिर सर लगता है just explain that.
You're standing here, na? It is rotating about center of mass, isn't it?
Yes.
So वो distance कितना था radius का?
L by root.
L by root 2 alpha, right?
हाँ.
So ये point A का, if you see the acceleration, it is going down also. It is also going with L alpha by root 2, ना? और ये 45 है ना?
One
उसका
sec, sir.
component
The
लिया मैंने.
direction.
Tangential. It's going in a circle. Everything rotates about the center of mass, isn't it?
Yes.
So यहाँ से acceleration क्या होगा? इस तरफ होगा ना?
अरे
Alpha.
हाँ right. I got confused in the direction part. That's why I was able to figure it out.
ये
And
होगा L
so,
alpha by root 2 sin 45. बोलो.
sir, COM में हम लोग ने जब किया था, there was this question in which there was this rod falling and there were two blocks beneath, and then we were using conservation and all. But sir,
हाँ,
वो
कौन सा
अगर
क्वेश्चन था वो?
sir, 1 minute, let me just check. 45.
यहाँ पे कंजर्वेशन यूज नहीं किया हमने. We
No,
use
the
restitution
conservation.
ना.
हाँ, restitution
कहाँ
से
था?
जो. So
हम्म.
sir, what my doubt was कि अगर हम इस क्वेश्चन को करने जाए तो वो रोटेट होगा ना रॉड?
After collision.
नहीं, बिफोर नहीं होगा क्योंकि masses
Before
are
collision
not.
दोनों का दोनों. हाँ. So that means according to you, from a building, if I drop m and 2m, both will reach with different speeds. Kinematics में कितना बार हमने मास किया?
नहीं, स्पीड की बात नहीं है सर. आई एम टॉकिंग अबाउट द टाइम टेकन टू रीच बिकॉज इट विल रोटेट.
Why
आई एम
will it
जस्ट
rotate? बता ना, why will it rotate?
बिकॉज टॉक अबाउट वेट.
Which point? Torque about which point? सेंट्रोमस लेना पड़ेगा तुझे. एंड सेंट्रोमस सेंटर में नहीं है.
नो, इतना तो पता है, बट व्हाट इफ वी टेक टॉक अबाउट एनी वन ऑफ द बॉडीज देन
देन
व्हाट?
सूडो फोर्स अप्लाई करो ना. सूडो फोर्स अप्लाई करो. बिकॉज इफ टेक एनी अदर पॉइंट, उसका सूडो फोर्स आएगा.
यस.
अरे
अरे
देख ना अनुषा, सिंपली लॉजिक ना. स्पीड दोनों का यू तो ओमेगा 0 है.
हाँ.
एंड फोर्स जो भी है, अगर चलो कुछ फोर्स भी है तो टेंशन हॉरिजॉन्टल है. mg नीचे है तो t इज इक्वल टू 0 ना. देयर इज नो हॉरिजॉन्टल फोर्सेस.
ओके, आई विल जस्ट सी टू इट अगेन.
हाँ,
तो
तेरा
रोटेशन
लॉजिक क्या है,
करने
मैं
के
सेंटर
बाद
पे
सब
लेंगे
कुछ
अगर.
रोटेट होगा.
यहाँ पे अगर इफ यू टेक एनी अदर पॉइंट ना, इस पॉइंट का खुद का एक्सेस है ना जी, तो इफ यू स्टैंड हियर, उस पे सूडो फोर्स लगाना पड़ेगा. देन
यस
इफ यू
यस.
टेक टॉर्क यू विल गेट 0.
ऑलराइट.
सेंट्रोमस लेना चाहिए था. बिकॉज
नहीं,
इफ
वो
यू टेक
सेंटर ऑफ
सेंट्रोमस
मास लेके
हियर,
मुझे जीरो आया, बट देन व्हेन आई वाज
एल
डूइंग
बाय
विद द
3 टू
बॉडी
एल
आई
बाय
गॉट
3.
कंफ्यूज. या. नहीं, वो सेंटर ऑफ मास से मेरे को समझा कि सेंटर ऑफ मास से जीरो आएगा, बट देन आई वाज वंडरिंग कि बॉडी से क्यों नहीं आएगा, एंड देन आई गॉट कंफ्यूज कि वो बस
सूडो
रियलाइज है
फोर्स.
सीधा लगेगा.
इफ यू रिमेंबर, वो स्टेटमेंट वही था. इफ यू रिमेंबर दिस स्टेटमेंट व्हिच वी रोट, ये क्या था थर्ड पॉइंट? टॉर्क अबाउट हिंज सेंटर ऑफ मास एनी पॉइंट इन इनर्शियल फ्रेम. तुझे और कोई दूसरा पॉइंट लेना तो टॉर्क इंक्लूड करो सूडो फोर्स का.
हम्म.
दैट्स व्हाट बोल रहा हूं ना. व्हेनेवर यू सी सिस्टम ना, ऑलवेज चेक, लाइक यू आर रोलिंग ऑन ए ग्राउंड, तो बॉटम मोस्ट पॉइंट hinge, center of mass. Other than these 3 points, normally you'll not find anything.
या. ओके.
Generally, rarely we take an on inertial frame. वो बाद में करते हैं वो भी. Clear?
या.
चलो ठीक है, ब्रेक. कम बैक 5 मिनट में.
यस सर.
Comes on everyone. So that's the kinetic energy of your rotation. Now, if you take kinetic energy of a rolling body, so when you say a rolling body, it has one translation plus rotation. So if you have body going with V and omega, you can split this motion into translation. R omega R, the rotation. So, and if you remember this formula we derived in here, where center of mass, kinetic energy of a system is kinetic energy of center of mass plus kinetic energy about center of mass. So this is kinetic energy of center of mass plus kinetic energy about center of mass. So basically this thing is the translational component. This is your rotational component. Rm V COM square plus half I center of mass omega square. Check it out. Yeah. But there's a problem. Randomly apply this for any type of system. You have to be clear that the system contains a translation plus rotation. So let me show you a more generalized one. That's why we specifically wrote a rolling body करके.
The ICOM is just the moment of inertia of the body, right?
Moment of inertia about center of mass. There is nothing like moment of inertia of a body.
Yeah, right.
Because depending on axis, it can change, isn't it?
Yeah.
Now, if you go a little further, right? Now, this thing actually comes from thermodynamics. We have something called degrees of freedom. I'm sure you must have heard about it. So this is simply the number of independent ways a system can possess energy. So if you're going X, Y, Z, you can have a rotation. You can have a rotation in this direction, X-axis. You can have a rotation in Y-axis. You can have a rotation in Z-axis. Remember point of rotation we discussed. So then there are three translations. We'll not get into the triatomic molecule, all that is there. For us, this much is sufficient. So this would be half m vx square plus half m vy square. But what we do generally, right? We just take the entire thing to be one speed, vx square plus vy square plus vz square. So physics, normally we don't write it as three different components. We can just say for a body, it is three kinetic energies. Plus this would be half ix omega x square. So a body will have different momentum inertia about different axes, and you can have different rotations. Half iy omega y square, half iz omega z square. So you have to be clear. Are you talking about translation plus rotation or rotation plus rotation? Let me give you a problem. You'll understand better. So, but a system can possess energies in different degrees of freedom. There is no guarantee every time it will be translation plus rotation. For example, remember I gave an example in the beginning, translation rotation mein. A swinging table fan. It's double rotation. Have a look at this. Let's see a question. So we have a rod here, thin rod, mass m, length L, and there is a disc here, mass m, radius r, disc. The disc is rotating with omega 2, and this whole system is rotating with omega 1. You're getting how it is rotating? Find the kinetic energy of the system. So this is like a disk rotates about the central axis. And it is connected to a rod which rotates with omega 1 as shown. Find kinetic energy of the system. This is like a swinging table fan. You have your own rotation and you have a revolution also. Now, if you see here, there is no translation here. So if you write the formula half mv com square plus half I com omega square, you'll be gone. Get the energy of the system. Try. I'll give you a minute. Think about it. It's a good one. mr square. Let's see. See, we can divide this into two parts. The disk. So I'll call this thing kinetic energy of rotation. Okay, we'll call it rotation and revolution. Technically, both are same. So this guy would be half. I would be mr square by 2 because it's a perpendicular axis, omega 2 square. Agreed? Because it's a thin rod, moment of inertia of rod is negligible. The second one, you're rotating about this axis, omega 1. So first about this axis, the moment of inertia is mr square by 4. About this axis should be mr square by 4 plus ml square. This is the parallax theorem. This is for the disk. And the rod is ml square by 3. This is for the rod. So you have to find the moment of inertia about the axis. So this is the kinetic energy of revolution. Which is half. The moment of inertia of the system is ml square by 3 for the rod. mr square by 4 plus ml square omega 1 square. Check. Add them and that is your answer. The kinetic energy of the system is K1 plus K2. So in this case, both the degrees of freedom are rotational. There is no translation here. So before starting a problem, you need to check whether there is a translation plus rotation, rotation, exactly what. So don't use that formula half mv cum square plus half I cm omega square. For this kind of problem, it doesn't work. Have a look at this. It's a good one. Clear? Aditya, clear? Lakshika, clear, na? Palaksh, Rehan, Ali, clear? Yes, Yasha, got this? Next one. Turn in the page. So we have a bowl kind of thing here. On the left-hand side, it is rough. There is no slipping. The right-hand side is smooth. We have a solid sphere. Mass and radius r is released from height h. So when the ball comes here, find v when it reaches a. Now remember, it's all, I told you how to use work power energy. The question is find v at the lowest position. Means I don't care what is happening in the middle. So what you do, step 1, draw the final diagram. Step 2, define your initial final state. Step 3, use conservations. Find v when speed is at a. That is fine. That's an easy one. Find the maximum height on the smooth surface. And the max height on smooth surface. Let's get this. What is the speed? That's an easy one, right? नहीं यार ये इतना weird नहीं आएगा. God, there's no slipping. See, I'll help you with the first one. State 1, state 2, defined here anyways. So this is state 1, this is state 2. There's no slipping, that means friction is not doing any work. Why? At the point of contact, velocity is 0. So what is the power due to friction? F into V is 0. So what friction does here actually is, it takes energy from translation and gives it to rotation. So as such, there's no energy loss. Remember, static friction does not do, meaning in this case, static friction does 0 work here. So energy in state 1 is equal to energy in state 2. So initial energy mgh, final energy half mv square plus half I omega square. So mgh plus half mv square, it's a solid sphere, plus half 2 by 5 mr square omega square. R omega is v, so half mv square plus 1 by 5 mv square. V will be root over 10 gh by 7. Because at this point the velocity will be v minus r omega, which is v ground, which is 0. There we got the velocity. That's an easy one. If you see it is exactly like work per inch, the only extra thing is this half I omega square will keep coming up now. That rotational component you have to include. What about the maximum height? After this, how much height will it go on the smooth surface? That's a good one. Try. I'll give you a minute. Right, Arjun. What is the catch? On a smooth surface, if you observe, mg, normal reaction, friction is 0. Therefore, torque about center of mass is 0. Therefore, alpha is 0. Therefore, omega is constant. So once you enter the smooth surface, there is no torque to change omega. So the body will continue to rotate. So at the highest point, velocity will be 0, but it is still going with same omega. Getting the catch? There is no one to change omega. So the body will just keep rolling at the highest point there and comes back again. So at H max, body is still rolling. Body is rotating. But it is slipping. There's a smooth surface. So let this be state 3. So energy in state 2 is equal to energy in state 3. Half mv square, half I omega square is mgh plus half I omega square, cancels off. You get h is equal to 5h by 7. Take v from here and substitute. Omega is not given, right? You can't give answers in omega. All answers should be in terms of capital H. Have a look at this.
If it was falling from the smooth thing, you could have directly used the kinematic equations, right?
Then to rolling nahi hoga na. Then you would have got root 2 gh.
Yeah.
I can ask you something even more interesting now. Now listen. After coming here, now it will come back, right? Listening? Now it will come back. Now what height will it go here? Will it go back to the same height? Why? Why not? Got my question? Now it's going to come back. After reaching here, V is 0, right? But mg is still there, so it is going to come back. Will it go to the same height? Yes or no?
No, sir.
Why?
So because now the velocity that it will gain from the potential energy, that won't be the same.
Same, no? Why? Why it won't be same? With
Because
whatever speed you went, you'll come back with the same speed. Why? Where is it losing energy? It's a smooth surface, right? Here, if it is V, when you come back, you'll get V only. Omega is decreasing. Why omega will decrease, Rakshika? Torque is different. What are you talking? There's no torque only, right? Got from here to here. Friction is 0.
So
It
can
won't
you
go to the
explain
same height.
after omega is constant?
Nothing. Which one?
Can you explain after omega is constant?
I just conserved energy here and here. So this height be h, no? So when it reaches the highest point, velocity is 0, but omega is not 0. So then conserve energy between state 2 and state 3. So in both the states, this rotational energy will be same. Fair enough? Anyone can tell me why it won't go to the same height? It won't go to the same height. That is the answer. But why? I want to see whether you can figure it out.
So will omega and velocity be in different directions? That's why.
So you're close by. So
basically, इसके बाद I'm not-
rotating opposite direction, that is weird, right? Because देखो अभी क्या होगा? Omega will be this way, but V will be this way, na? At the bottommost point, velocity is V plus R omega now. It will skid. And friction becomes kinetic. And if it's a kinetic friction, you will lose energy. You won't go to the same height. Are you getting the catch? The omega ka direction will still remain same, but V ka direction will change. That is the difference there. Got the catch? So you are going with V this way, but you'll come back with V this way. Omega direction is still same. So at the bottommost point, now velocity is not 0 when it comes back. So it will start skidding. And if it skids, you lose energy. Next one. So we have an incline here. This is a hollow shell. Mass M, radius R. It is filled with non-viscous water. Non-viscous meaning there's no friction. Mass is small m and radius is R. Same thing, it is basically filled. This height is h till the bottom. So don't worry about that. There's no slipping. So there are two cases here. Case 1, it is water. Case 2, water is frozen to ice, sticking to the shell. You froze it to ice, it became ice ball. Normally they won't say it is sticking and all. They'll simply say is frozen to ice. So it is understood it will stick. Sticking to shell. So find the velocity when it reaches the ground. In both the cases. Case 1, you have water, which is no friction. Case 2, it becomes ice ball. And remember, always they'll ask find V and they'll say no slipping. Means you need to understand there is an omega. They won't mention in the diagram. So be careful. If you see the word no slipping, it is understood omega is there. Let's get this. So these questions are, if you see this one are based on translation and rotational concepts, which we did in center of mass introduction. What is a translation motion? What is a rotational motion? Get this? C2 same as previous. Nah, mass of the water is small m, mass of the shell is capital M. Quite different. Don't treat the entire thing as a solid sphere. That's a blunder. You can't treat the whole thing as a solid sphere. Huh, Arjun?
The center of mass is at a high depth, right? Or like the bottom.
Ground bottom only. Because when it comes to the ground, again, यहाँ पे भी center mass होगा ना r height में.
Right.
Basically, I want difference in height to be h. That is fine. H or h plus r का difference है. Ouch. Let's get this. It's a good one. A simpler mains level question will be in which case the speed will be more. Case 1 or case 2. That would be a simple mains level question. Calculate the speeds. Try. You got 2 minutes. Try. Just give me a minute. Right, Utsa. What is the logic there? What is the catch here? In the first case, that when it is filled with water, water does not rotate, isn't it? Water will simply translate. But second case, my ice ball will rotate. That's the difference, isn't it? So, if you look at both the cases, if this is filled with water, so this is how it looks. See. So if I choose 2 points, now A on the shell and B inside the water, and C here, when this thing has come here, this is what would happen. A must have gone somewhere here, whereas B will still be there. C will still be here. You're getting it? The water will just translate. Water translates without rotation. So you don't take the rotational component. So we can write the statement loss in potential energy is equal to gain in kinetic energy. Loss in PE is equal to gain in KE. So loss in potential energy here will be M plus small m GH. You have to include both the masses. Half mv square plus half 2 by 3 mr square omega square. This is for the shell. Plus half small m v square. That's it. There's only translation. You don't include rotation. This is the water. Only translation. Whereas in the B part, and V is equal to R omega. That is anyway there. This has become an ice ball, so the whole thing will rotate. So if you choose this point as A and this point as B, after some time, if A comes here, B also will come here. A and B will be together. So here the statement will be M plus MGH will be half MB square plus half 2 by 3 MR square omega square. The shell plus half small m v square plus half 2 by 5 small m r square omega square. This is for the ice ball. Now it's a solid sphere room, but this is a shell. That's the difference. So who will have more speed? Water or ice? Water, no? Because some of the energy will go for rotation in ice. So it'll have less translation. The water will have more translation energy, so it'll have more speed. Please check the steps. Not difficult. That one term will make the whole difference between an ice ball and water. Sure, everyone? Any doubts on this?
So the word non-viscous tells us that it's not rotating the water.
Non-viscous meaning friction nahi hai.
Okay.
Can't we consider the system as one ball of mass m plus n? Great. Now listen with that problem, okay? If you take the whole thing as one ball, is it a uniform ball? You mean to say the ice and the shell will have same density? So you can't treat it as a solid sphere, right? 2 by 5 m plus m r square. For the shell, all the mass is on the surface, whereas for the water, it is distributed everywhere. You have to treat them as two different systems. They're not one and the same. Okay? That's why you can't do that. Any doubts on this? Simple one, good one. Next one. Let's see the next one. Next one, if you got it, then we can say like you understood actually energy, everything. This thing and best part, you have seen this problem. This is a deadlier version. So we have a solid sphere. Mass m, radius is smaller. The wedge is mass 2m. Ground is smooth. Remember this question?
Yes, sir.
Right, Anusha, that is the reason. Because there is no friction, right? There is no one to rotate the water. For example, if you have a non-viscous water in your bucket and put your hand and rotate, it will not rotate. Your hand will simply slip. So this surface, right, there's no slipping. Meaning between the ball and the wedge, it has friction. This is point A. And this track radius is R. Everyone remembers this question? So ball is gently pushed. Find the speed and the normal reaction when it reaches A. This would be another proper advanced paragraph question. Let's get this. Solid sphere, mass m, radius small r. The wedge is 2m. The r capital R is the radius of the track. So if the ball is released from rest, find the speed and then the normal reaction when it reaches the point A. How do we do this? rotates with omega. There's no slipping, huh? Think about it. If it slides, again, see, I think you guys are getting confused between no slipping and rolling. In that problem, right, which we did, if there is no friction, this ball will simply glide, isn't it? At this bottommost point, there is a relative velocity, means it is slipping. Don't get confused between slipping and rolling. They both have no relation to each other technically. No slipping meaning simply at the point of contact, there's no relative velocity. In this scenario, the ball will go to the right and the wedge will go to the left. So definitely there's a relative velocity. If the ball does not rotate, it will slip. That rotation is needed not to slip. Root 5 GR minus RY. Okay, that. Okay, it is R only, Aditya. The difference in height is R only, na? When it reaches A, the centrum is still at height of small r. So smaller nahi aayega answer mein, but it was right. If you just remove the smaller, you are right. Others, get it. I told you this thing. Whenever you see a question, first thing you need to figure out whether I have to use torque and force equations, that is FBD, or should I use conservations. It is clear in this. I'm asking you find the speed and normal reaction at A. So you're asking speed at A, means you want speed at some final position. So indirectly, it's talking about state 2. Nee, Arjun, that is wrong. So first thing what you do when you have to use conservation, draw the final diagram properly. Getting it? Whenever you use force and torque, you have to draw FBD properly. Whenever you have to use conservation, you have to draw the final diagram properly. So draw your final diagram. So this guy is going with V2. This ball is going with V1 and omega. Since there are no horizontal forces, conservation of horizontal momentum. Ground is smooth. Friction is internal between them. Initial momentum is equal to final momentum. Momentum is conserved. So initial momentum 0, final is mv1 minus 2mv2. Both are not going with the same speed. This is equation 1. Next thing, energy conservation. Loss in PE is equal to gain in kinetic energy. So if you observe here, the center of mass has gone from here to here. So that is still R only. mgr is equal to half mv1 square plus half, it's a solid sphere, so 2 by 5 mr square omega square plus half 2m v2 square. This is for the wedge and this is for the ball. Till here, actually, most people get it. Then they do the goof up. They write v is equal to r omega. What is no slipping condition? See clearly here. This guy is going with v1 and this guy is going with omega. The bottom surface is going with v2 backward. No slipping condition is at the point of contact. The velocity should be same. R omega minus v1. So R omega minus v1 is equal to v2. That is your no slipping condition. If you have written v is equal to r omega, that's the blunder. At the point of contact, you should write. And I know v2 is v1 by 2. So r omega minus v1 is equal to v1 by 2. So v1 will be 2r omega by 3. This was your equation 3. Please check. See where you messed up, Lakshika. That's not the answer, I guess. So now substitute mgr of mv1 square. This is 1 by 5. R omega is how much? R omega is 3v1 by 2 ka square plus m v2 square. That is v2 is v1 by 2 ka whole square. mgr. This guy is half mv1 square plus 9 by 10 mv1 square plus mv1 square by 4. This doesn't look good. 3 by 4 plus 9 by 10. Did I goof up somewhere? Maybe you're right, Lakshika. I don't know. What is this? No, this is not 20, no? This is 20 yoga. 4, 5, okay.
20 होगा नीचे.
Multiply 5, 3, 15. 15 plus 9. 24. 24 by 20. 6, 4, 6 by 5. 6 by 5 MV square. Shit. This is MGR. So V is equal to root over 5GR by 6. Okay, you found V2, okay? Okay, then you're right. This is your V1. Then you'll get V2 also. Please check. Most common mistake, na, this is what people goof up. The no slipping condition. Remaining, I'm sure you must have got it also. See where it went wrong. The momentum, energy, no slipping condition. There are 3 parts in this problem. Clear? Then what about the normal reaction? That comes the next one if you remember again. So when you draw the FBD, now be careful here. Normal reaction, mg, you are going in a circle. So there will be a centripetal acceleration, which is v relative square by radius, which is r minus r. You have to take the radius of the center of mass at distance lena hai. So it's not r. And what is v relative here? v1 minus of minus v2 ka square by r minus r. Hope you remember this. So normal reaction will be mg plus m v1 plus v2 whole square by r minus r. There you have NLM, momentum, circular motion, energy, no slipping condition. 4 chapters. Hope everyone remembers this part here. V relative square by radius. Here the radius is the radius of the center of mass to the center. Because the idea here is this guy is going with V1, but your center itself is going with V2. So when you stand on the center, you think it is going in a circle. Centripetal acceleration is towards the center. This is acceleration. What you're saying is centrifugal force.
Sir, but won't that be downwards? MV square by R.
Centrifugal force will be downwards. Then it is a force, right? This is an acceleration, right?
Okay, okay.
N minus mg is m into AC. Now, if you write centrifugal force, it will come on the left hand side. Same thing. All clear with this? Any doubts on this? It's a good one. Can I turn the page? Any doubts on this page? Please ask me. The momentum, the energy, and the no slipping condition. Perfect. Last one for the day. We have a tightly wound carpet. Meaning there's no space between them. Tightly wound cylindrical carpet. So you can treat it like a solid cylinder. Mass M and radius R. Then someone gently pushed it. So this thing started rolling down. So this radius was R, and this radius became R by 2. Why is this taking so time? Think of like this. You must have seen the movies where hero comes and kicks the carpet and the red carpet just goes there and he walks. ऐसा कुछ. So at this point here, this thing is rolling and going here, and there's no slipping here, meaning whatever carpet is on the floor that comes to rest moment it touches. Basically, it is always at rest. To find the speed and omega, find speed when the radius becomes half. Carpet starts rolling without slipping as shown. Find speed when the radius becomes half. Is the diagram clear? We have a fully round carpet. It's like a cylinder. Mass m, radius r. Someone just pushed it, that started rolling down on its own. Find the speed when the radius becomes half. What do you think is the answer? Same thing, state 1, state 2, energy, conservation. Story is always the same. I draw you the final diagram also here. So initially the center of mass is here at height r by r. Mass is m. Now the center of mass is at r by 2. And what is the mass? M by 4 and r by 2, isn't it? The volume, mass depends on volume. So here this mass m will be density into pi r square L. Here mass would be density pi r by 2 whole square L. So this is m by 4. The length of this carpet will be same. This length will be same. What changes is the radius. You're done. So loss in P is gain in kinetic energy. You just have to be careful with the terms because the mass has become m by 4. So loss in potential energy, initially you are having mgr minus, now the potential energy is m by 4 g r by 2. Isn't it? Mass has changed, radius has changed. So loss in potential energy is initially mgr, now it is m by 4 g r by 2 is equal to half, velocity is half m by 4 v square plus half I omega square, where I will be, it's like a disk, m by 4 whole square, m by 4 r by 2 whole square by 2. And don't forget, no slipping condition, V is equal to R by 2 omega. It's a solid cylinder, it's a disk, right? And remember, V is not equal to R omega. V is R omega by 2 because radius has become half. Check the steps. There's one more thing. Sub karke na, people that V is equal to R omega. You can get trapped. That V is equal to R omega thing is a big blunder. You have to be very careful when to use that. Please check this thing. Meaning it looks easy, but that because of that M by 4, everything will change. You have to be careful. There's a high chance you'll goof up some part. So here we have a system whose mass is also changing, height is also changing. So loss in PE, it will not be mg delta h. Since it's not slipping, there's no loss of energy. Have a look at this. It's a good one. Simple one. It's a good one, but explain the I omega moment of inertia. This is the I moment of inertia ka value.
but
mr square.
m mass का velocity नहीं होगा कुछ initially.
Kiska? Which one?
Initially, the m mass
It
won't
is-
it have any velocity?
It is just gently pushed. So initial velocity is 0.
Okay.
Carpet rolls on its own, if you observe any time. Because it has more energy, gentle push, it will go off. It is gently pushed. So initially there's no kinetic energy. All clear with this? Got the change in potential energy, kinetic energy part. Check it out. Ask me if you're confused. Yeah, so that's the last one for the day. So next class when we meet, right, we are going to continue with more problems. We have more better ones. This is just like starting introduction ones. And then we will do even something called instantaneous axis of rotation.